In this lesson, we'll be looking at non-proportional relationships. By the end of the lesson, you should be able to determine if a relationship is non-proportional and then represent non-proportional situations graphically with a table and using an equation. So in a non-proportional relationship, again, we have two sets of data. They will show a constant rate of change, and it can be represented in tables, graphs, and equations. So to check for non-proportionality, the graph is a straight line, but it will not go through the origin. It will go through a different y-intercept. We can find the ratio of y divided by x, and if we get different quotients, it's not proportional. If we cross multiply and the results are not the same, it's non-proportional. And our equation is going to look like y equals mx, and then you're going to have another number here, this b. If there's another number, it's non-proportional. So you can see in this graph, it is not proportional because the y-intercept is 2. The line is not going down here through the 0, 0. From the table, we can also tell that it's non-proportional because, again, our y-intercept is not 0, 0. If I cross-multiply two ordered pairs, I will not get the same result. And when I take the y value divided by the x, my quotients are different. So for example, this says make a table of values and graph the solutions for the non-proportional equation. So I look at this equation, I immediately know it's non-proportional. So if I fill in the numbers, and then I'll come over here and graph it, I can see immediately it's not proportional. How can I tell? Well, it doesn't go through 0, 0. If I cross multiply any of the ordered pairs, 1 times 1 is 1, and 0 times 3 is 0, so that doesn't work. If I take the y values divided by the x, 1 divided by 0 is 0, 3 divided by 1 is 3, and 5 divided by 2 is 2.5. So all of those reasons show it's not proportional. The following table shows the relationship between persons' years of experience and their hourly pay. So are our cross products equal? We're going to try to see if this is non-proportional. No. 4 times 14 is not the same as 2 times 19. Are the quotients the same? No. 19 divided by 4 is not the same as 26 divided by 6. What is the slope? Well, we can still find the slope because it's the change in y over the change in x, because we know that non-proportional is still got a constant rate of change. What is the hourly pay at 0 years experience? Well, we can see right there it's $9. So if I write the equation, it's y equals 5/2 x, that's my slope, plus 9. That's my y-intercept. So let's look at these three examples and decide. Is it proportional or non-proportional? So at this one, are the cross products equal? No. Are the quotients equal? No. Does it go through the origin? No. What's our equation? Y equals 5x plus 3. I've got this plus 3 here, so that means it's non-proportional. Let's look at the next one. What about our cross products? Cross multiply? No. What about quotients? -3 divided by 2, -1 divided by 1? No. Does it go through the origin? No. Right here it's showing us the y-intercept is 1. What's the equation? Y equals -2x plus 1. The 1 is showing us it's non-proportional. All right, let's look at this third example. How about cross products? -1 times -1 is +1, and -2 times -1/2 is also +1. All right, let's check some quotients. 0.5, or a half, divided by 1 is a half, and 1 divided by 2 is a half. How about the origin? Yes, we can see here we've got the 0, 0. So it does go through the origin, so our equation would be y equals 1/2 x. No extra number. So how do you find slope? Remember, it's y minus y, y2 minus y1 over x2 minus x1. What shape is the graph of a non-proportional relationship? It's still a straight line, it just doesn't go through the origin.